So thank you very much to be with us today. So you are representing 3 projects funded by the European Union under Horizon 2020. This project has been funded under also the Ocean Energy Eranet Cofund. So a Cofund project between region and the European Union that promotes the marine energy. So we have today Patrick running from ORPC representing the Optimor project, Mark McCaig from Here Composites from the project Seablade, and Luciana Das Neves from IMDC representing the project We See for Port. So, and Karen Fraser, who is the coordinator of the project Ocean Energy Eranet Cofund, that will maybe introduce in few sentences the project, the objective of the project and the Cofund.
Thank you. Yeah, welcome everybody. I'm just going to say a few words about Ocean Energy Eranet Cofund. Basically, this is an initiative funded by the European Commission under the Horizon 2020 programme, but also by 8 national and regional funding agencies in Europe, and the countries that have got a particular interest in the thriving of the ocean energy sector. We have organised 2 joint calls for transnational collaborative research and development projects, and I'm very pleased to be here today with a number of the projects who can now present their results, which are very exciting. So I'm going to pass on to the project.
So maybe a few words about your project, Patrick, Optimor.
Hello everybody, my name is Patrick Cronin. I'm a Director of European Operations at ORPC. ORPC are a river and tidal project developer based in the US. We have subsidiaries in Canada, Europe, and in Chile in South America. Our technology is based around our modular and highly efficient cross-flow turbine. We have a range of products across river and tidal applications. Our RivGen system is a 80 kilowatt power system currently deployed in Igiugig, Alaska, which is a small fishing village. These areas usually pay about 10 times as much of power for the national grid price, so it's very important for them to have cheaper power. We also have our tidal energy device, TideGen, which is a 80 to 120 kilowatt device. This is for tidal locations, obviously. The modularity of our turbines means that essentially for us to increase power, we just increase the amount of turbines in the system. Same generator, etc. is used. And our market research has shown that for us to be competitive in a European market, a scaling up of this technology is needed, which is what the Optimor project is about. It's about kind of re-envisioning how we approach the utility scale devices for deployment in Europe. There's obviously significant technical challenges when it comes to this type of work. Your structure gets a lot bigger, your turbine. I'll run through the slides here. So the Optimor project, stands for Optimized Buoyant Crossflow Tidal Energy System for Mooring in Deep Ocean Rock Beds. So we've teamed up with Sustainable Marine. Their Swift Anchor system is a very high holding anchor system, and they have a ROV that can essentially deploy the system in one scenario, essentially. So the system drops to the seafloor and drills and tensions the mooring in one operation. So obviously that appeals to us. As we start getting into megawatt scale, we need mega holding power. The project has been oriented around concept development and then the mooring for the deep ocean rock beds that we'll be deploying in. There's basically our project line, our product line that I described earlier. With RivGen on the left, and then Optimor. Unfortunately, this is just a mock-up concept image. We can't actually show you what it really looks like, unfortunately, just due to the sensitivity of it. But here we see our largest turbine system, and this is basically as large as we can go with our current turbine range. So essentially after this, we have to redesign the turbine to hit a megawatt scale. The project objectives, as you can see, are to reduce the LCOE by about 60% to a very, very competitive level. This device is in the concept phase, so to get us to a competitive level by the time it's fully developed, we need to be aiming at these kinds of costs per kilowatt hour. So overall, I suppose from the actual Optimor project, what we have is a preliminary design level design and some preliminary anchoring system designed as well. Yeah, that's pretty much the summary.
Okay. So thank you very much, Patrick. And then we will have Mark, who will present the Seablade project.
Thanks, Thomas. Mark McKaig is my name. I'm Chief Commercial Officer of Eranet Composites. Eranet Composites are an Irish company involved in lightweight composites materials. We're 60 people spread across 6,000 square meters with about 600 years of combined experience of manufacturing lightweight composite materials for space, aerospace, and renewable energy. The Seablade project, I might just pop to the next slide and that'll do. The Seablade project is the blade you can see there in the photograph. So it involves taking Eranet Composites' proprietary composite powder epoxy technology, using that to manufacture an 8-meter turbine blade for a 2-megawatt device and testing that blade. Partners in the project were Eranet Composites, Orbital Marine Power, based in Scotland, and the National University of Ireland, Galway. That's it. Thanks.
Perfect. Thank you very much. And then Luciana for the project we see for ports and representing the company IMDC.
Thank you very much, Thomas. I'm very glad to be here to present a hybrid wave energy converter for ports. So this is a project that is a follow-up for another project where we developed a hybrid wave energy converter for implementation in breakwaters, in sea breakwaters. So the main idea of this project, and I forgot to mention, so I'm working at IMDC, and IMDC is a company that is mostly interested in coastal engineering, the design of coastal structures, but also coastal offshore and inland waters. We are much interested in the breakwater. So we partnered with the University of Porto and INEGI, and also our colleagues Eranet Composites for the manufacturing of a new turbine. So the main purpose of this project, the main idea is really to have a multi-purpose breakwater. So the idea is that breakwaters, the idea is that they dissipate wave energy, which means that there's some energy that can be captured, and therefore providing useful energy. So the idea is that we still have a breakwater that shelters port operations, but it also has the co-benefit of energy production. And then, as I mentioned before, it also hybridizes two power generating technologies, an oscillating water column and a wave overtopping device. So the purpose of the project is to progress this concept to a TRL6. We are currently doing numerical modeling, physical modeling, and some more numerical modeling, calibrated and validated with the physical model tests. And our final goal is actually to test the new rotor and of the new turbine at Motrico in the Basque Country.
Okay, so thank you very much for this presentation. And now I will ask you some questions, because sometimes European projects can be challenging, and many companies also say that it can be difficult to get in there and then to run it, because it can be with some administrative burden and a lot of stuff. But we would like to get also your feedback today about how you experienced this European project in terms of partnerships, in terms of fitting with your needs and fitting with your projects, and how the real life projects happened in European funding. So maybe I can start with a question toward the main benefits this European funding, except funding brought to your project and to your needs? And maybe how did it allow to remove obstacles for research, maybe about the risk and de-risking some of your projects? So I don't know if you have any answer about that.
We're lucky enough actually to work with Sustainable Marine already in a project that's being deployed in the summer in Cobscook Bay. It's our Tygen 80 unit. But this project allowed us to kind of go back to the drawing board a little bit and, go to Sustainable Marine and just kind of lay out what we were planning on doing and getting their experts, advice in terms of operations, the mooring system. And, just that knowledge transfer between the partners was very beneficial. I suppose we have good experience dealing with European partners. The expertise, you just have to look around today to see the amount of expertise in Europe. But our bread and butter is working with European companies, research and development. We work with Eranet Composites very closely. We're currently working on a Crimson project, which is investigating sustainable materials in our turbines. So this is kind of it's not new to us, but it's been very beneficial, I find, because now we have preliminary design of a concept that may not have been being able to be thought up of without funding.
Thanks, Paddy. For us in Eranet Composites, I think with regard to working with partners and the administrative burden to address that question, we don't see it as a difficulty. We think it's fine, and it gives us a huge opportunity to work with great partners throughout Europe. Like as Paddy said, we work with ORPC on a separate project, and with IMDC with Lucinda as well on this WEC for Ports project. But with regard to the project I'm presenting here today, Seablade, I think the key benefit for us in availing of the European funding is the technology that we were trying to drive and bring up through the TRL levels in this project was CPET, which was our proprietary material technology. It's a new technology. Tidal turbine and tidal energy is also a new technology. And when you're bringing two new technologies like that together, the risk appetite is very rarely there without European funding to de-risk that, or some form of funding to de-risk that. I mean, the natural way for a tidal energy company to go without funding would be to look at more tried and tested technology, such as maybe resin infusion, for example, for the blades, because they're already doing amazing new stuff with the energy converters. So for us, the funding is vital for us to be able to integrate our new technologies at an early stage, and going to become even more vital as we try to integrate sustainable technologies and materials at an early part of device development.
Adding to what was already said, I think also the fact that the Eranet is more sizable, more small partnerships, I think this helps quite a lot. Because indeed we have a smaller partnership, we have a touch base with our partners, and indeed we couldn't do this project without our partners. So it's essential for that, and it also helps us to not only research and development other areas, but also to strengthen our core business. In the case of IMDC, we are strengthening our core business of coastal structures. In this sense, the project is really, really good.
And did you have experience in European project before the Eranet, or was it the first time you were on European project?
No, so actually the Dublin office of ORPC was started on the back of some national funding in Ireland and also some European funding. We finished up 2 years ago a very interesting project, just challenging some of the maintenance and design of our generator and power electronics. So we've had good experience. We were dealing with a lot of good companies there as well. Providers from all over Europe. That generator design is now our standard design. So there's great value there for us as well. And as I mentioned, we work with Eranet Composites as well on a number of projects. And actually, an interesting enough piece of information is the market research that aligned us to the Optimor was European funded as well. So it's European and nationally funded. You can see the track the whole way to where we are now.
Yeah, not a first time for us either. Whilst my youthful good looks might give the game away, our composites are around since 1998. It was originally a spin out from the National University of Ireland in Galway. Been involved in projects right back as far as FP7, Horizon 2020, Horizon Europe, and ESA funded projects. So we're well used to it.
Yes, I'm here. Some experience with FP7 and Horizon Europe and yeah. But still, I think Eranet, because of its smaller partnerships, I think it's a special one.
So again, like, would you like to continue this kind of project, or do you plan to have other project, or maybe a continuation of this project toward European funding, or toward another kind of framework?
Yeah, so from the Eranet project, essentially, we have a number of proposals currently under evaluation through national and European funding schemes. It's definitely tweaked the interest as well of our other offices around the world as well. So it's been very beneficial, and it's work we will most certainly be taking on into the future and assessing further. Yeah.
Yeah, likewise for us, it was really beneficial. We are still talking to all the partners on the project about commercialising the technology, and we work closely with the NUIG on many projects. We continue to work with RPC, and we will certainly be able to take the technology forward, the project forward, and the project really truly helped us to commercialise the technology.
Same here. We hope to continue progressing the wave energy converter, the hybrid wave energy converter, to further, TRL, higher TRL.
I was asking that because it's always important to not think in terms of just one project, but include it in some broader picture for your companies, but also for the European Commission to have a broader picture of the project and to continue them towards new programs and make them progress and finalize some products or some elements. And so we've discussed about the European dimension of your partnerships. But was it, of course, it was an added value, but do you have some feedbacks about that? Could you have done the same work within your country, or was it really an added value to have European partners?
Yeah, I suppose in Ireland we're lucky enough to have academic institutes like NUI Galway, who have their large structures test lab on the west coast there of Ireland, very close to Air Composites, which is very convenient for testing, quick scale stuff. We also have the Lear National Ocean Test Facility in the south of Ireland as well. We've done some previous work with them as well. Actually, as part of the SEI Access program, we did a 1:50 scale test of the Optimor in their test tank as part of another project, which was great to have something tangible out of the project. But of course, Europe offers something that you can't just get in Ireland alone, and that. We're getting better in Ireland for sure. We're definitely a player amongst, but I think it's a teamwork attitude, I think, in Europe, and I think that's how it works so well, I think. Yeah, exactly, yeah.
For us also, we're very proud of the infrastructure we have in Ireland. Obviously, the Seablade project, the device developer in this project was not Irish based, so purely for this project, it would be nearly impossible to do it without European partners. But to us, we feel it's maybe somewhat of a strategic advantage being an island nation in Ireland that for decades, really, we've had to rely on and be comfortable collaborating across Europe. And, these type of mechanisms just help us to do more of that.
Yeah, definitely. We can also leverage, because of this partnership, we can, from a commercial point of view, we can also leverage other markets and get to know other markets. So in the sense, it's, of course, we couldn't do it without the other partners. It's good also to have different industries, academia, and therefore from different nationalities. I think it's an added value.
And maybe one last question. I will ask, what should you say to companies that is considering submitting a European project proposal, but is hesitating? Or do you have any advice or any tips?
Yeah, if they want, they can come to us if they have something very innovative. But I suppose we're always open to collaboration in seriousness, I suppose. But advice-wise, I would say read the call text, make sure what you're proposing before you start to liaise with other partners. Just make sure that you're clear about what you want to do. And if you're ever unsure, maybe contact your national contact point for the European Commission, and they can put you in the right direction.
For me, just to add to that, it's be not afraid. Just go and do it, and begin with the end in mind, and consider your commercial goals and objectives. And I think begin with that in mind. Consider what you're trying to achieve and what you're trying to do, your commercial goals and objectives, and perhaps maybe try to join a consortium rather than lead a project for the first time around. Look at the work packages first and kind of map out the work being done, and then see if the journey around that would fit an open call rather than trying to get something just into a call. And there's a lot of opportunities out there, so just go and get involved.
Yeah, indeed. I think the first step is the hardest. So you need to get involved in EU research funded. That's why we have some experience and we continue to do it. So once you have that first step, then the others are much easier, I think.
So thank you very much for your valuable testimonies, and I wish you the best for the future of your project.